Good morning. First, small introduction. We did this presentation for the two main reasons. The one, the barometer pressure sensor calibration is quite a hot topic. Yesterday was presented some talks about influence, what the wrong pressure measurement can do to the station coordinates. And secondly, our station has some kind of strange range biases. And when we started, actually the part of the work was done more than 5 years ago, because we know that we have somewhere a problem. And we decided to start step by step. We first tested the time and frequency system, and next victim was our pressure sensors. Okay, first a brief history, what we have used over the time since the stations start to operate in 1987. Very large period of time we use the aneroid, which is from Ericsson, or with accuracy about 0.0 millibar or hectopascal. Since 2007, we have WISAL WXT meteorological outdoor system, which measures the pressure, temperature, humidity, wind, precipitation, and so on, with a reported accuracy about 0.1 millibar, with a small reference. It is valid only for one temperature. Our wider temperature range is actually lower, about 0.15. And since 2016, we operate yet another unit, PTU 300, which is as an auxiliary one, and is installed in the telescope compartment. And we tested, we're using the reference pressure sensor, which is used for calibration purposes, which was kindly lended by the GFC Potsdam. The GE DPI 141, this is a model sensor, which has accuracy about 0.01 millibar. So, about our station layout. So here is, you see here is winter picture. It is not the latest one, we have some changes, but nevertheless, our WISAL outdoor station installed here. You can see the picture. It's not the proper installation. It was the most convenient. So this is another story. But it operates outdoors. And WISAL PTU 300 is installed as a telescope building. So it's partially in the picture here on the upper right corner. It monitors the conditions in the telescope compartment. When we open, we have the rolling roof. It's fully exposed to the elements. If closed, it's kind of monitoring what's happening in the telescope compartment. So, about the height differences. The height we verified also. So, the height difference between the telescope reference point and the PTU, not the PTU and WISAL, is correctly recorded in the telescope log, so there is no problem. And this unit is installed in the same height as a telescope reference point. So, and now comes the results. We did multiple sessions. It's not something like one day effort. The recording was done over even weeks in different seasons. So we get the data about the different temperature ranges and the time spans. And here are some sample results. Okay, so first it's small. So the leveling was done with the students did it seriously. So we measure where to put the drug, and we had this opportunity to put this reference barometer in the same height as the sensor against we calibrated. So to avoid any additional reduction about height differences and so on. And of course, this reference sensor was in the room temperature, so it's counted as stable. So here is some sample results. So on the left, oops, sorry. So on the left, there is one typical day, year 2016. Temperature range from 2.7 degrees up to 20. And this is a plot which shows the pressure in the millibars. This is 1 day. And you can see that Weissel versus WATX 510 versus this reference sensor matches pretty well as specified by the manufacturer. So this is basically, despite this about 18 temperature difference during the day, it matches quite well, and there is no systematics. With PTU300, again, there is a longer session done in 2018. There is a small catch. The PTU300 appears to have about 0.1 millibar systematic shift. So in the green, it's but otherwise, again, it matches pretty well the reference barometer. So, and at the bottom, there is a small summary, and this is just a sample. For the rest of the days, the picture is the same. So it's pretty remarkable, stable. So, and what happens now? Here is just from recent. We don't have this reference barometer now, but we can compare our PTU300 with our second sensor. We know the height difference. We know that PTU300 has this small systematic shift. And again, we see if you take into the account the height difference and the systematic shift, again, we can see that both devices matches pretty well, according, not exceeding what the manufacturer specification says. And again, the temperature range in this case is from 16 degrees to 32. It's August this year. I think where is the date? Okay, on top August 5 this year. And we did also for other days or even weeks. The picture doesn't change. So what we have left is our old aneroid. We are doing it as let's say, as a kind of background activity because this one you have to read manually. But again, even this device doesn't show any systematics. Yes, it's not so precise, but it matches pretty well within its precision with our other pressure sensors. So we can conclude that since 2007, or maybe earlier, we don't have any, let's say, large error in pressure sensors. We may have some drift or what, maybe, but not some extra value, large values, let's say, 1 millibar or so. And of course, to some other, yes, this is maybe a common knowledge that this pressure sensor better to have in the constant temperature, and it's good to have more than one pressure sensor. And now briefly what we plan to do. We would like to repeat the calibrations and probably send this WVXT to the factory for the calibration and upgrade. And we would like to install a new meteo station which conforms to the WMO, this World Meteorological Organization guidelines, to have the proper temperature reading, to have the precipitation, wind measurements, because we also are doing groundwater measurement on a regular basis, so it will complement it. And also to get an idea about the temperature biases, because our temperature, this Weissel meteo station, is installed in a way which was convenient, but it's not the proper way. And we really would like to have also this, like this Druk DPI device to have as a reference, so we can safely say that our pressure measurements are, let's say, always within the limits. That's all. Thank you for your attention. And thanks for Kalvis Postdom for lending this reference pressure sensor.
Thank you, Kalvis. Any questions from the audience? Okay, I think that concludes our before coffee break. Oh, we have one question from the audience.
Can you please raise your hand so I know where I'm going? Sorry, I don't have a question, but a few comments. And as everybody knows, since several years in Graz, we have seen very strange drift in our range biases, and we only have that was the reason from our old non-calibrated barometers. And when we realized this problem, we start to contact our local weather authorities, because they might have a long-term records nearby, and then you can somehow compare to your record. And also after that, we calibrate our data and correct our data and resubmit. And there are many things to do. And also another comment is, and now we have 3 barometers in our station, because it's easy to compare. If you have 2 and you don't know which one is, when there's some drift, you don't know which one is the correct. And the last comment is, maybe you have seen the talk from Jose, I think on Monday, and there are some modeling, and this you can maybe make some study out of that. I think we, in our community, we should be more focused on that. Yeah, thank you.
Great, thank you very much. This concludes this section. We'll return again at 11:15-ish. Yes.